Hi, today is all about substitution. First problem is y equals 7x plus 4 and y equals 9x minus 6. Now, if y is equal to this and if y is equal to this, then we can set these equal to each other because that equals y and that equals y. So now we just have one big equation where we can solve for x. You could put the x's on either side. I'm going to move this over here, but if you did the opposite, that's great too. You don't have to move the x's first. You could move the numbers first. In fact, there's 4 correct first steps right here. So you could actually pause, solve how you think you're going to solve, and see if you get the same thing. So we have negative 2x plus 4 equals negative 6. To solve for x, you would subtract 4 from both sides. So negative 2x equals negative 10. And then when you divide by negative 2, you're getting x is equal to 5. Now, the solution of two equations, remember yesterday how we were graphing and the point where they cross is the solution? So we need to figure out the y value for the solution. So it doesn't matter which initial equation you plug 5 into, you should get the same answer. And what's cool, that's a great way to test yourself to see if you did it right. So I'm going to plug it into both. So we're going to go right in here. Y equals 7 times 5 plus 4. That's 35 plus 4. So that's 39. So I'm pretty sure the ordered pair point is 539, but I'm going to check that right here. So I can actually plug this in for y and this in for x and see if it works, or just plug the 5 in for the x. Either way works. So y equals 9 times 5 minus 6. That's 45 minus 6, and yep, that is 39. So for sure, this is the right answer. You can internally celebrate, and we're going to do another problem. All right, problem number 2, here it is. Y equals negative x plus 9, y equals 2x plus 30. If you think you know how to do it, hit pause and try it. So since y is equal to negative x plus 9, and since y is also equal to 2x plus 30, we can write that negative x plus 9 is equal to 2x plus 30. So this is the place where you have 4 correct first steps. I really like my letters on the left, so I'm going to go ahead and subtract the 2x. That is not the only correct first step. So if you want to do something different, do that now and check up in a minute. So negative 3x plus 9 is equal to 30. Now that the letters are on the left, the numbers need to be on the opposite side. So we're going to subtract 9. So negative 3x is equal to 21. And then when you divide by negative 3, you're going to get x equals negative 7. Now remember, the solution to a system is an ordered pair point. So you need to plug in the negative 7 either here or here in for x and see which one works. So I'm going to do both because if they're both the same, we know we did it right. So y equals negative because of that negative, and then you're plugging in negative 7, no x there because we plugged it in for x. We plugged negative 7 in for x. It's a substitute. Just like when a substitute teacher comes in for your teacher, the teacher leaves. So negative 7 is actually positive 7, and then we still have that plus 9. So 7 plus 9 is 16. Pretty positive our ordered pair solution is negative 7, 16. This being the x and this being the y. But we're going to check that using this other equation. So you could either plug negative 7 into this equation to check, or you could plug negative 7 in for x and 16 in for y and check. So I'm going to just do this whole thing. So 16 goes in for this y right here equals 2 times x, but instead of x, we're substituting in the -7, and then you have the plus 30 still. So if this works, we are going to be certain that that's correct. So 16 equals -14 plus 30, and look at that. It's a great moment to be alive. That is the correct answer for sure. All right, back to our third problem, solving by substitution. Now, right here, this is showing that y is equal to x plus 2. So instead of this being y, we can substitute x plus 2 in for it. So we're going to rewrite this whole top equation, 3x plus 2. But instead of y, it's going to read x plus 2 because it's an equivalent substitute. Just like if you're going to substitute fries for onion rings, hopefully it's equivalent. You can just whip one in and take the other out. All right, equals 14 is the rest of this equation. So in order to solve for x, a number next to a parentheses means multiply. So you're going to need to distribute that 2 to both things in the parentheses. So now you have 3x plus 2x plus 4 is equal to 14. So 3x and 2x are like terms. You could put them together first on the same side. You could move the 4 first if you want. You just need to get all of your like terms together, all of your x's on one side, and all of your numbers on the other. So now the numbers need to be all together on the opposite side of the x. And then when you solve for x, a number next to a letter means multiplication. So you would divide by 5 to solve for x. So x is equal to 2. Again, we're looking for the point where these two lines cross. So we need the y. You're going to plug this into either. The bottom one is definitely easier to plug it into. So that's where I'm going to start. Y equals 2 goes in for x plus this 2. So right now, y is equal to 4. So the ordered pair point should be 2, 4. But what's so great about this unit is you can take this point and plug it into this equation that we didn't use to solve and just make sure it works. And then if it works, you're 100% positive you're right. So 3x, 3 times 2, because this is the x value, plus 2 times the y value, which is 4, does that actually equal 14? Well, 6 plus 8 does equal 14, so hooray. You know you're right. This is definitely the solution. 2, 4 is the place that these two lines cross. Our next problem now we have 3x plus 51 equals 8y, and y equals -6x. So since y is equal to -6x, we're going to substitute the -6x in for this y. It's kind of weird because the y is on the right this time, and we're used to the y being on the left. So 3x plus 51 is equal to 8, and then instead of y, we're putting in y's substitute, which is -6x. So this -6x just substituted in for that y because it's equal to y. It's its equivalent. So 3x plus 51 is equal to -48x. Now, usually we bring all of the letters to the left, but this time there's numbers only on the left. So let's bring all of the letters to the right to be together and let the numbers stay on the left. So to move this 3x, you need to subtract 3x. You're doing the opposite. So 51 is equal to -51x. So now to solve for x, you're going to divide by -51. And look how nicely that came out. -1 is equal to x. I'm going to go ahead and just rewrite this as x is equal to -1. That's called the commutative property. You can write it either way. Okay, so We need an ordered pair point, a solution where these two linear equations cross. We have our x. We're going to go back up here and solve for y. So this one looks a bit easier to plug into than that one, so I'm going to pick the bottom one. So we're substituting this -1 in for this x. So y equals -6 times -1. X is -1. That's your substitution. So y is equal to +6. -6 times -1 is +6. So right now we're pretty certain the ordered pair solution is -1, that's the x value, and +6, that's the y value. So we're just going to check this to make sure by plugging it back into that first equation, because it's just, to know you're right is a very good feeling. Just going to plug this in to check right here. So 3 times x, which is -1, plus 51, does that equal 8 times y, which is 6? So 3 times -1 is -3, and -3 plus 51, does that equal 48? That's what 8 times 6 is. Yes, it does. So we are 100%, we are correct. -1, 6 is the ordered pair solution where these two linear equations cross. It is the one point that works for both of these equations. Fun problem to do. X equals 5y minus 26, and 6x plus y is equal to -1. Now, this time, the x is the thing that's isolated and alone, and x is equivalent to this 5y minus 26. So instead of substituting in for y, we're going to substitute in for x. X is the thing that has an equivalent substitute. So we're going to rewrite this bottom equation with one letter, and that one letter is going to be y because we're substituting the y in for x. So instead of x, we are writing 5y minus 26, and then we still have the plus y equals -1. Okay, so 6 times 5y is 30, whoops, minus 6 times -26 is 156, I did that earlier, plus y equals -1. All right, a y alone is the same thing as a 1y. So if it helps you to put that 1 there, do that. 30y plus 1y is 31y. Minus the 156 equals -1. So these were on the same side of the equal sign, so we just put them together. So 156, we need to do the opposite to move it to the opposite side of the equal sign. So we're going to be adding 156. So now we have 31y equaling 155. So when you divide by 31, I also did this earlier, you get 5. All right, we want an ordered pair point for where these two linear equations cross. So we're going to plug 5 in. Are one of these seeming easier to plug 5 in for y? I'm thinking that the bottom one's actually easier to plug 5 in for y. You could plug it into the top one, and then we can compare answers in just a minute. So 6x plus, this time our y is what our substitute is, equals -1. So in order to solve for x, we're needing to put the numbers together on the opposite side of the equal sign. So 6x is equal to -6. And then when you divide by 6, -6 divided by 6 is -1. So right now, we are pretty darn sure that -15 is the answer. But just to be certain, to know that you have 100% on this, you're going to plug this into the equation that wasn't used to solve it. So -1 is going to go in for x, and 5 is going to go in for y. We're just checking to make sure this point works, to know that it was a solution to that whole equation. So -1, does it equal 5 times this 5 going in for y? minus 26. Well, negative 1 is equal to 25 minus 26. So we are 100% certain that that is the ordered pair solution to the two linear equations that made up that initial system. The next problem is 7x plus 2y equals 18 and x equals y. So you can actually substitute y in for x because y equals x, or you could substitute x in for y because y equals x. So pick which way you want to do it, and I'm going to substitute y in for x first. Doesn't matter. So 7y plus 2y is equal to 18. So 9y is equal to 18. So y is equal to 2 because you would divide by 9. You could actually solve the other substitution if you want. So if you chose to substitute x in for y, you would have had 7x plus 2x equals 18. That also gives 9x equaling 18. So x is equal to 2. So it looks like our ordered pair point is 2, 2. Well, it definitely works for that one. And we just saw that it works for this one right here. So we're right. 4x minus 2y equals 24. X minus y equals 5. Now, this time, we don't have something lovelily set up to substitute. So let's remember how yesterday we put things in y equals mx plus b? So let's go ahead and do that. So we're going to get the y alone by subtracting x. And you could also get the x alone. It's actually easier. I'm going to keep going with what I started here, because watching these negatives is a very good thing to do too. So you see that negative y? We're solving for positive y. So we're going to multiply the whole entire thing by negative 1, every single term. You can also think about that as dividing by negative 1. So this is really y. So we're really not looking at this part or this part. The two equations that we're working with are these two. So this is now set up to substitute because we have something that y is equal to. So up here, instead of y, we're going to be substituting this x minus 5. So let's write that now. 4x minus 2, and then instead of y, in comes the substitute of x minus 5, and then back to the equals 24 part of the equation. So it's really important to notice this minus. You could make the minus plus a negative because those mean the same things. Or when you distribute this, you could make sure that you're distributing a negative 2. I like to make my minuses plus a negative. I call it slash and dash. That use slash to make it positive and change the sign behind it, because minus 2 is the same thing as plus negative 2. So regardless of which way you're going to choose to do it, you are distributing a negative 2, and that's very important. So 4x plus negative 2x plus positive 10 is equal to 24. Negative 2 times negative 5. If you lost that negative to the 5, maybe you should take that minus and also make it plus a negative, because negative 2 times negative 5 is positive 10. All right, well, the 4x and the 2x are on the same side of the equation, so we can put these together with like terms. We're just adding them. 4x and negative 2x is 2x. Plus 10 equals 24. And then we're going to put all the numbers together on the opposite side that the letters are on. So the negative 10 is going to subtract, and we're going to have 2x equals 14. Initially, you could have subtracted the negative 10 first. There's definitely more than one way to arrive at this answer. So when you divide by 2, x is equal to 7. So now remember, we're always solving for an ordered pair point. We have the x value for where these two lines cross. We still need the y value. So you're going to plug x equals 7 either into this equation, You could plug it into this equation, or you could plug it into this equation that we simplified. When I scan these, I'm thinking this one looks the easiest to plug into, but you are going to choose for yourself. So y equals, instead of x, we're substituting 7 minus 5. So now the solution is y equals 2. The ordered pair point then is 7, 2, x, y. Over 7 up 2 is the point where these two linear equations cross each other. But again, let's check and make sure. So we solved it with this equation, so we're going to check it with this equation. So 4 times, instead of x, we're plugging in the 7, minus 2, and then instead of y, we're substituting that 2, equals 24. So the question is, does this work? So 4 times 7 is 28, 2 times 2 is 4, and yes, that does equal 24. What a great way to end this lesson, again, knowing that that was solved correctly. I hope you learned something and enjoyed the time learning. Have a great day.